Now we see how to compute the variance that will be robust to clustering. So when there is clustering, we say that y uh, it depends on the groups you are, because yg is equal to xg times beta plus ug. So we have this, that it is for every g from 1 to capital G. So the fact is that the expected value of the squared residual for each group given x will be equal to some matrix sigma G, while the expected value of whole the whole set of residual will be equal to omega c. This c stands obviously for clustering. So for every group there is a intra-cluster correlation. So the residuals of each cluster tend to be obviously within the cluster, it tends to be similar to each other. So actually the variance of each cluster will be different. It is very likely. So the whole variance, that is the expected value of the square residual, will be equal to omega c, that will be equal to a squared matrix, where on the main diagonal we have the group's variance, the cluster variances. So we have got sigma 1, sigma 2, until we get to sigma g. All the other elements will be equal to 0. Now, since we don't know the actual value of the variance, we estimate it by omega hat c. It will be equal to a matrix, a square matrix, where the sigmas are substituted by our estimated ones. So on the main diagonal we have our estimated sigmas, and all the other elements are equal to 0. Now, so every estimated sigma will be equal to the estimated to the expected value of the squared estimated residuals. So sigma g, the estimated sigma g, will be equal to the expected value of the product of u estimated ug times estimated ug transposed given x. So if we want to compute the variance of beta, then it will be as usual, as the expected value we have to expand our beta. So we know that beta is equal to beta plus x transposed x inverse times x transposed u. So we are taking the variance. The variance of beta will be equal to the variance of this part. So the estimated variance of the estimated beta will be equal to the variance of x transpose x to the power of minus 1 inverse times x transposed u estimated. So this will be equal to x transpose x inverse times x transpose the expected value of u estimated u times estimated u transpose given x times x transpose x inverse. We know we define this to be equal to omega c hat. So the cluster robust variance of the OLS estimator when there is clustering, it is equal to x transposed x inverse times x transposed omega c times x transposed x inverse.